Good morning, students. Today we are going to revisit recursion. In the previous video, we studied about recursion, we understood what recursion is, and then we saw how we can use recursion to display the sum of first n natural numbers. We also saw a function where recursion had been introduced to us. We understood that in Python, recursion has a limit, and we can even change that limit of recursion. We can change the maximum limit. You all know that for changing the limit, we use the function setRecursorLimit. And where is that function? That function is in sys module. One more function we saw. That function was getRecursionLimit. It gives us the recursion limit that is currently being used by the Python interpreter. By default, we saw that recursion limit was 1000. In this given video, we are going to take factorial of n terms, that is factorial of a number n, and then we'll go to see Fibonacci series. Now, Fibonacci series, we'll first understand what Fibonacci series is, and then we'll see how a recursion function can be written for Fibonacci series as well. So let us proceed further. And as we proceed, let us again take a recap of what we learnt in the previous video. We all know what is a recursion. Recursion is a way of writing program in which the function being defined calls itself. The function which is being defined calls itself. That means the body part of the function being defined has the calling statement in it. So we'll go, and what we'll do is we'll seek few functions for implementing factorial of n and Fibonacci series till n terms. See, students, we have already done a function to display sum of first n natural numbers. Today we will write function using recursion to display factorial of n, and then we will see how a function can be written using recursion to display Fibonacci series up to n terms. In the next video that would follow, we will take up searching of a number from a list of numbers using binary search algorithm. So let us proceed further and try to write a function first for displaying factorial of n. But before going to that, let us again recapitulate few things. Do you remember how we formulated a recursive code? What was the plan we took to formulate a recursive code? How we actually think of as a programmer while we are trying to make a recursion function? You would remember that for writing a recursive function successfully, we need two conditions. A programmer has to take into consideration two conditions. The first one was the terminating case. Now, what was terminating case? Terminating case means that given execution of the function where the function gives back a definite minimum value to us. You saw when we were talking of finding sum of n natural numbers, we got a definite minimum value 1 when 1 was passed to the sum function. So similarly, for finding the factorial also, we will have to first take into consideration, find out the terminating case, and then we will go and find the recursive case. So this is how we formulate any given recursion or recursive function. So we need to first identify the terminating case and then the recursive case. Now what is a recursive case? A recursive case is a case which takes help of the terminating case to do its work. The recursive case is the generic case, and terminating case is the case which gives us a definite minimum value. So let us proceed further and go to understand that our approach would be to identify the terminating case and the recursive case for finding the factorial of n. So let us start. So we have now, I have written this as topic 2. Why? Because in the first video for recursion, we have completed our first topic, that was finding sum of n natural numbers. So here we are ready to find the factorial of n. So students, let us try to write a function fact_n. We will write this function in Python. And what this function does? It finds the factorial of n. What is n? N is a number which is being passed to the function factorial. So this function is fact function, and it takes n as parameter and finds the factorial of that number n. Let us see first, or I should say, let us first analyze what the factorial means and how fact_n should work. So we'll understand how our function has to work, and for that I have made a table. See this table. It takes many cases and helps us understand how factorial is actually calculated and how fact_n should work. Let us take the first case. See, in the first case, fact function is being passed with 0. Now we all know in mathematics that factorial of 0 is 1. So I have to write a function where whenever n gets 0, we should get back 1. Because fact 0 should return 1 to us. We also know that fact 1, that is, if I want the factorial of 1, in mathematics even, 1 factorial is 1. So fact 1 should give back 1 to us. So if somebody asks you, what is the minimum value that fact_n can give back to us? So you'll obviously say that that minimum value is 1. Now we also understand that that 1 is not given by one fact function only. Two fact functions are capable of giving that minimum value. That is, fact when passed with 0, it also gives 1. And fact when passed with 1, it would also give us 1. So we have two terminating cases here, because both of them gives back a definite minimum value. That value is 1. So fact 0 also gives us 1 and fact 1 also gives us 1. That means if n is equal to 0, then also we will get back 1, and when n is equal to 1, then also we will get back 1. So students, we can well understand here that there are two terminating cases. One when n is 0 and the second one is when n is 1. So from this given discussion, we actually understand that we have two given terminating cases for the function fact. Why we have two given terminating cases? Because these two functions, that is both of them, fact 0 and fact 1, gives us back, that is returns us back the value 1. And you can see the chart, the third column. 1 is the minimum value that fact function can give us. Because see, if we go for fact 2, then it is going to give us 2. If I go for fact 3, it gives us 6. If I go for fact 4, it gives us 24. If I go for fact 5, it gives us 120. And if I go for fact 10, it gives us the factorial of n, obviously greater than 1, if the value passed to n is more than 1. So we have two terminating cases for fact 10. Let us again revisit fact 2, that is when we pass 2 to factorial function. The function which we have written here is for factorials finding is fact. So fact 2. See, if human beings had to find the factorial, the human brain would have thought in this given way, 2 into 1. And it would have said, okay, the result would be 2. If we asked a human brain to find factorial of 3, the human brain would have said, okay, factorial of 3, that means 3 into 2 into 1. Okay, it is 6. But computer doesn't work in this fashion. Computer works in a different fashion. We'll see it in a few moments, how computer does the work. But from the discussion here, one thing has been clear to us, that there are two terminating cases, fact 0 and fact 1. So we have to find terminating cases and recursive case. So we have already found the terminating case for factorial of n. The terminating case is, you can well see, the terminating case is, actually there are two terminating cases. Fact 0 would give us 1 and fact 1 will also give us 1. That is, when n is passed with 0, it gives back 1. When even n is passed with 1, it gives back 1. This is to be remembered, students, because this is the thing which we would be using for coding our function of factorial, that is finding factorial of n. We will use this information, the terminating case information, for it. Now let us go and find the recursive case. So we will now find the recursive case. Now for even recursive case, we will see a table, and understand from it. See, this is the table. Now you see, in this table there are 3 columns. The second column actually shows how human brain is going to answer when he or she is asked to give the value of the factorial. And column 3 shows how computer is going to do the same work. Now computer, for fact 0 or fact 1, is going to directly return 1. We'll code it in such a way that the terminating case would be taken care of in the code and they would directly return back 1 to us. But when it comes to fact 2, we humans would have written or thought 2 into 1, but the computer actually changes fact 2 into a statement that is 2 into fact 1. Now 2 into fact 1, you all can understand. That means when fact 2 is called, fact 2 is going to take the help of fact 1. It is going to say fact 1 that fact 1, please help me out. So now the control goes to fact 1. Fact 1 has to give the answer back. And as we all know, fact 1 has a definite answer. The answer is 1. It returns 1. And now fact 2 understands that, okay, fact 1 returned 1 to me. So 2 into 1 is 2. Therefore, fact 2 will now say the whole answer is 2. So how did it work? See, when we called fact 2 called fact 1. Fact 1 gave the result back, a definite minimum result it gave back. That result was used by fact 2. And fact 2 understood that the end result is 2. Now students, again if I ask you a question, which function was called first? Fact 2 or fact 1? So you will say, we all know fact 2 was called first and then fact 1 was called. Now if I ask you, which function completed its work first? Fact 2 or fact 1? Now you will say, fact 1, sir. Fact 1 completed its work. It gave the value 1 back to fact 2. Then fact 2 completed the work. So if again I say that a Python interpreter is using stacks, it keeps fact 2 into the stack first. It pushes fact 2 into the stack first. Then it pushes fact 1. But who comes out first? Who completes its work first? Fact 1 completes. And then fact 2 completes. So it is all being done using a stack. So again I will iterate that recursive cases, that is recursion functions, always use stack for its completion. Now in this way we all know now that fact 3 is going to call fact 2, fact 2 is going to call fact 1, and then fact 1 is going to give the answer first, then fact 2 is going to give the answer to fact 3. So you all know how fact 3 would work. Fact 3, when called, it is going to call fact 2. Fact 2 when called, it is going to call fact 1. Fact 1 would complete first, then fact 2 would complete its work, and then fact 3 would complete its work and give the result 6. So I think you have understood how here 3 times fact function is working, and it is working by the help of a stack. Let us now go to the case which is actually asked by the question. The question has asked about fact 10. Now how fact 10 is to be interpreted by the human brain? Now fact 10 is to be interpreted by the human brain as n into n minus 1 into n minus 2 into n minus 3, in this way. In human brain, this is actually to work. But how computer is going to do the work? See, computer is to use n into fact n minus 1. So n into fact n minus 1 means what? That means if you see the lines above that line n into fact n minus 1, you will well understand how we got that given expression n into fact n minus 1. See, 4 into fact 3. If we consider n to be 4, then n minus 1 is going to be 3. Now see, 3 into fact 2. If we consider n to be 3, then n minus 1 is 2. If we consider n to be 2, then n minus 1 would be 1. So this fact 10 is the generic case of all the cases above which were showing recursion. See, fact 1 was not showing recursion. Fact 0 was also not showing recursion. They were terminating the recursion. But fact 2 actually called fact function twice. So it recurred it twice. Fact 3 recurred the fact function, or I should say called the fact function thrice. So recursive cases are from fact 2, fact 3, fact 4 till fact 10. And we are interested in fact 10. We have to find the factorial of n. So we are going to take n into fact n minus 1 as our recursive case. This is our recursive case because we have to find the factorial of n. So what is our recursive case? So our recursive case is fact n is equal to n into fact n minus 1. Let us proceed further and see the findings. So terminating case, when n is equal to 0 or n is equal to 1, that is fact 0 is going to give us 1, even fact 1 is going to give us 1. Now we go to recursive case. Now in recursive case, we all know that fact n is going to be written as n into fact n minus 1. These two given findings will help us to code the factorial function, that is the function fact, which takes n as parameter. So let us go and see the code. See, this is the code. See, so simple it is to write the code. We have two cases. I have defined a function fact, passed n as parameter. As we had two cases, see, if n is equal to 0 or n is equal to 1, in both the cases, what to get back, what to be returned? 1 is to be returned. So return 1. And else, that means for all other cases, we have written return n into fact n minus 1. So we have only written down the terminating case and the recursive case. And you can well see in the recursive case, the function fact has been called from within itself. So it is a recursion. When this function is to work, say if I pass 0 to p, then it is going to return back 1 and 1 will be displayed. Now when I give 1 to p, so the function is going to get n as 1 and it is again going to return back 1 to us. And if I say I give a number, say 5, you can well see the output. The factorial function is giving the output 120. So students, I think you have well understood how the factorial function is working for us. This is how the factorial function does it work. So it works in this fashion. Now it is time for us to go and find the Fibonacci series. So let us now go and try to find a code, write a code using recursion for Fibonacci series. Now let us first understand, students, what is a Fibonacci series. And for understanding, we'll see a table. See, we have to write a function called Fibo and we are passing n to it. N is the number of terms. Now students, there is a difference between the previous two programs and this program. The previous two programs had to give only one output on the screen. But here we have to actually give more than one outputs. See, the table shows it. What we have to do? We have to give, when FIVO 0 works, we want to display 0. When FIVO 1 works, we would display 1. But when FIVO 2 works, we have to display 0 and 1 both. Why? Because 2 is in n and it means n has 2 terms. So 2 things have to be displayed. But students, FIVO 2 by itself would not be able to display 2 things. It has to use, or I should say call, 2 FIVO functions for its work. When FIVO 2 would be passed, it is going to call FIVO 1 and FIVO 0. FIVO 0 is going to give back 0 and FIVO 1 is going to give back 1, and therefore FIVO 2 can do its work twice. So each FIVO function can return back one value only. Earlier also, each sum function, each fact function used to return back one value only. But we used to add those values or find the factorial of those values and displayed the end result. But here, as and when a value is given back, we have to display the value then and there. So please keep that in mind. Now, how does a Fibonacci series work? To understand how Fibonacci series work, we will go to FIVO 3. Now FIVO 3 shows 0, 1, 1. How it shows we have understood. Fibonacci 3 is going to take help of Fibonacci 2 and Fibonacci 1. We'll see how it takes the help afterwards. But for a human being, if I have been said to write a Fibonacci series with 3 terms, I will write 0, 1, 1. Can you see the second one in this series? How do you think that one came? Yes, that one is nothing but the summation of the previous 2 numbers in the series. See, the previous 2 numbers in that series is 0 and 1. And 0 and 1 when added, that is 0 plus 1 will give 1. So the third number is 1. If you go to FIVO 4, you see, in FIVO 4, we have 0, 1, 1, 2. What is the last number? The last number is 2. How did we get 2? See, the previous 2 numbers are 1 and 1. If you add both the numbers, it gives us 2. So Fibonacci series are a series whose nth term is actually the summation of n minus 2's term and n minus 2's value and n minus 1's term's value. That is, if n is taken to be 2 for say FIVO 4, then n minus 2's term is 1 and n minus 1th term is also 1. So 1 plus 1 makes 2. So it is summation of the previous 2 terms. The value in the previous 2 terms are added and then that value is kept at the next. If you see FIVO 5, 0, 1, 1, 2, 3, the last 3 is the summation of the previous 2 numbers, that is 1 and 2, it makes 3. 2 itself is a summation here of the previous 2 number, that is 1 and 1. And 1 is again the summation of the previous 2 number, that is 0 and 1. So for making a Fibonacci series, 2 numbers are required. The first 2 numbers are required. These 2 numbers would get added and then make the third number. The fourth number would be the addition of the second and third number. The fifth number would be the addition of the third and fourth number. In this way, Fibonacci series is made. It is being shown by FIVO n also. See, 0, 1, 1, 2. Now it proceeds. N minus 2, n minus 1, and the last term is sum of n minus 2's value and sum of and minus 1's value. So this is how Fibonacci series is created. But students, here we are actually trying to first find the terminating case. Now, as I said, for Fibonacci series, two numbers have to be there for increasing the Fibonacci series, for continuing the Fibonacci series. So here we'll have to take two terminating cases. We need that 0 also, and we need that 1 also. So as I said the definition earlier, that it should have the minimum definite value, I should have added minimum definite required value. Two numbers are required here. So we'll have Fibo 0 also, and we'll have Fibo 1 also as our terminating case. Even if 1 is greater than 0, but that 1 is also required. Two numbers are required. So the first two cases become the terminating cases here. So how many terminating cases we have for Fibonacci series? We have two terminating cases, Fibo 0 and Fibo 1. See students, the second column, I showed the second column to make you understand how actually we think of Fibonacci series. But computer executes the Fibonacci series in a different way. We will see how computer is going to run this Fibonacci series or display this Fibonacci series. So we'll keep that in mind, that we have to see how computer would do that Fibonacci series for us, and at that same time we have understood here that we have two given terminating cases, Fibo 0 and Fibo 1. So let us see our terminating case, and then we'll go for the recursive also. So terminating case. So what terminating case we have for Fibonacci series? See, we have two terminating cases. That is, when n is passed with 0, we will get back 0, and when n is passed with 1, we'll get back 1. Both of them are required for continuing the Fibonacci series. So students, keep it in mind. It would be used for coding Fibonacci series. Let us now try to find the recursive case. Again, we'll go for the recursive case. We'll analyze the recursive case, find the recursive case using a table. So we start the recursive case, and here is the table for us. See, the first two, Fibo 0 and Fibo 1, they are terminating cases. We have already talked of. See how Fibo 2 does the work. As I said, if Fibo 2 had to do the work, we would have thought, okay, Fibo 2, two terms, 0 and 1. But how our computer is going to do it? Our computer, when asked for Fibo 2, when set to execute Fibo 2, it is going to call Fibo 2 minus 2 and Fibo 2 minus 1. Now what is Fibo 2 minus 2? It is actually Fibo 0. What Fibo 0 is going to give us? So it is calling Fibo 0. When Fibo 2 is said, please work, it is going to request Fibo 0 and Fibo 2 minus 1, that is Fibo 1, to do the work for it. So Fibo 2 requests Fibo 0 and Fibo 1. It requests Fibo 0 first, and then it requests Fibo 1. Now Fibo 0 goes to work. That is, Fibo 0 is being knocked by Fibo 2. Fibo 0 gives back 0. So Fibo 2 minus 2 has 0 in its place. Now Fibo 1 goes for work because Fibo 1 has been knocked by Fibo 2. Fibo 1 gives back 1. So 0 plus 1 is 1, and we are going to display that 1. We are going to display that 1. Okay, so you understood how it works? Similarly, Fibo 3 had to work. Fibo 3 would have gone for Fibo 3 minus 2 and Fibo 3 minus 1. So Fibo 3 requests Fibo 3 minus 2. What is Fibo 3 minus 2? Fibo 3 minus 2 is Fibo 1. So Fibo 1 is returning 1 to us, and when Fibo 3 minus 2, that is Fibo 2 is being called, Fibo 2 is going to call Fibo 2 minus 2 and Fibo 2 minus 1. So when Fibo 3 minus 1, that is Fibo 2 is being called by Fibo 3, Fibo 2 is going to call Fibo 2 minus 2 and Fibo 2 minus 1. Now Fibo 2 minus 2 is Fibo 0. so it gives us 0. FIVO2 minus is FIVO1, so it gives back 1. 0 plus 1 is 1. Now FIVO2 understands that it is 1. FIVO2 then gives that information to FIVO3. So FIVO3 understands that okay, FIVO3 minus 1 is 1, and from FIVO3 minus 2 we already had got 1. So 1 plus 1 is 2. In this way it works. Now students, let us go to the generic case. That is the case for which we are working, that FIVO_n. So you can well see that FIVO_n would be actually calling FIVO_n minus 2 and FIVO_n minus 1 and then summing up the result. You can see this given expression we have got by seeing the expression, observing the expression above it. See, FIVO5 minus 2 plus FIVO5 minus 1. So if I consider n to be 5, then 5 minus 2 and 5 minus 1. If n is 4, then also 4 minus 2 and 4 minus 1. If n is 3, then also 3 minus 2, 3 minus 1. So our FIVO_n minus 2 plus FIVO_n minus 1 is the generic recursive case. Why I say these two be recursive cases? Because you see, from FIVO2, whenever FIVO2 is called, it is recursive because it is calling FIVO0 and FIVO1. It is calling itself twice. 3 FIVO functions are working for FIVO2. And if you see for FIVO3, how many FIVO functions are working? Now FIVO3 calls FIVO1. So 2 functions here, 2 FIVO functions. Now when FIVO2 was called, FIVO2 called again 2 more. So 2 plus 3, because 2 more, and FIVO2 itself. So 3 and earlier 2, 5 FIVO were being called. So you can see from FIVO2 it is all recursive. But we are actually interested in the generic recursive case, that is for us FIVO_n. So we have got our expression for the recursive case. What is that expression for the recursive case for us? See, FIVO_n would be written in the code as FIVO_n minus 2 plus FIVO_n minus 1. So we have got our terminating case for finding the Fibonacci series, and we have also got the recursive case for finding the Fibonacci series. So again summarizing, terminating case when n is equal to 0 or when n is equal to 1. So when FIVO gets 0 in parameter, it is going to give back 0. When FIVO gets 1 in parameter, it is going to give back 1. This would be used in our coding. And recursive case, see, for all other value of n, we would write FIVO_n minus 2 plus FIVO_n minus 1. So it is time now, students, to see the code. Let us go and see the code. See, this is the code. So simple to write Fibonacci series. See, we have a function FIVO which takes n as parameter. If n is equal to 0, it is going to return n. That means it is going to return 0. Or when n is equal to 1, it is going to return again n. That is, it is going to return 1. So the terminating case is actually been put properly in this given code. Now let us see the recursive case. Very simple. FIVO_n minus 2 plus FIVO_n minus 1 is going to be returned. FIVO_n minus 2 and FIVO_n minus 1 are being called recursively. When we are defining FIVO function, that FIVO function is calling 2 FIVO functions in the recursive case. So this is a code which uses recursion. And see here that each FIVO function is going to return 1 value. When FIVO0 is being called, when I say call FIVO0, it is going to return me 0. When FIVO1 is called, it is going to return me 1. When FIVO2 is called, we have already seen FIVO2 is going to call FIVO0 and it is going to call FIVO1. Now FIVO0 is going to give me 0 and FIVO1 is going to give me 1. So 0 plus 1 is 1. That is again being returned back. So in this way, each value which comes has to be printed. Because here we are not to add those values which comes or find factorial of the values which comes. We have to show the values that come. So whenever FIVO function would run, whatever value comes, then and there we have to show it on the screen. So we have to put FIVO or call FIVO from the main part of the Python code more than once. It can be even put in a loop. Students, I will again put a video, that is upload a video in which we'll practically do all these questions and we'll see the output practically, because they are screenshots which we are giving. Afterwards a video will also be uploaded to you, in which we will do it practically and see how it works. So students, we have talked of factorial and Fibonacci series using recursion. In the next video, we will talk of binary search algorithm, that is finding a number from a list of numbers using binary search algorithm with the help of recursion. So that is the next topic that we will go through. It is all for today. Thank you and have a very nice day.